Today we learn about the sounds, then what is the science work behind the sounds and the productions, the the propagation and how to be here. We learn about the all of things in this chapter. The chapter overview, the productions, how the sound is production was produced and production, and the hearing, how the human produce the sound and how they hear the sound. We learn about in this chapter and the properties of the sound like amplitude, frequency, pitches, loudness, and noise pollution. That is our chapter overview. Okay, so all of things we learn in this chapter. The first we learn about the production of sounds. How does sound actually originate? To learn how the sound is produced, first we learn what is the sound. If we understand what is the sound, we easily can understand how the sound is produced. Imagine a child in the toy shop. They crying for their favorite toy. They put all of energy. They put all energy in their body to make the sound, to make the noise, so their parents listen and buy to force to buy to a toy. It means the sound is a energy. Sound is energy like light and heat. The properties of light and heat is sometimes to same to with the sound energy, but all the properties of sound is may not cannot be same with the light or heat energy. Okay, so the sound is a energy. So if a sound is a energy, the energy have one law. We cannot be created or destroyed, only transform the energy to another. So we can understand these things, this line by this experiment. The one this example, and we clap with our hands, so we can convert the muscular energy into the sound energy. This energy travel towards in the wave. They eventually reach the listener ears to allowing to perceive the sound. So when you clap, the sound travel around the by the environment, and the listener can listen the sound. Okay, the vibration is the root cause of the all sound. Without the motion there is only of silence. The vibration is the main cause of the all sound. If vibration not happen, the sound is not happen. The motion is not happen, the silence everywhere is a silence. Okay, vibration cause of sounds. So vibration is defined as a rapid to and forth or back and forth motion of the object. What is first we understand what is the rapid to and forth and back and forth motion. When we understand this thing, then we easily can understand the what is the vibration. Okay, so when the object in the stable position, when we force it, it's go to extreme position A and then go the extreme position B, and then after the object come to the same mean position. Okay, it's called to and for, yeah, back and forth motion. Okay, it's also called acceleration motion. So when this motion do very rapidly, it's create vibration. When they create vibrations, they create the vibration create the sound. ठीक है? Okay, and this thing is the object is not behave like this, go like this, like this. Its motion like this. The the object go their main position to extreme point A to their same path to follow to of extreme A to extreme point B, and then after come X main point. This is a one. This is a one round, and we call this auxiliary motions. So when the object of when object vibrate, its force surrounding air to molecules to vibrate to as well. When object is vibrate, the surrounding air molecules, surrounding water molecules, surrounding solid molecules, they also vibrate and they transfer the sound energy. So we can listen the sound from one point to other point. These vibrations create the sound waves and we hear. We can explain this by this experiment. The striking a tuning fork make to its bronze vibrate invisibly fast. When we strike and we see in the air, we cannot see the vibration and very definely. If we dip those vibration tones into the when the fork is vibrate when the fork is vibrate and suddenly we dip the in the beaker of the water, you see the water splash visual proof of the rapid of motion. And the rapid when the rapid motion is happened, you listen to some sound. Okay, the sound. There some example of vibrating objects. The string instrument like guitar, sitar is a tightly stressed string. When we when we plucked their strings, they vibrate and produce a sound. Percussion instrument in the drum or tabla stress membrane or skin vibrate when the struck. Everyone have a dholak in their homes. So you see two side of the dholak, the stretch membrane, the stretch membrane was placed, and when we strike on this stretch membrane, the sound was produced. Okay, the wind instruments in the flute, the or trumpet, the column of the air enclosed inside the tubes vibrate. Here is here is the instrument by the wind, by the wind create create vibration in the tube, so sound was produced. The school bell, the every student dream. When the period was start, every boy, every girl, they attention on their school bell, so the when bell will hit, the period was over and they can freely freely walk on their campus. So the school wall made by the metallic plate or wall, and when forcefully hit by the hammers, they vibrate and the produce of sound. The propagation of sound. How does the sound is travel from the one source and to our ears? The sound was produced, but how we can listen? The distance between the object there is a sound produced and the person there who listen this sound. How the one point to sound it was travel and travel. So we understand how the sound was travel. So the sound need a medium. Sound every time need a medium. Without medium, the sound cannot travel. It means that in the space you cannot speak to someone directly because there is a vacuum in the space. So the there is a no medium. If medium in the space, you can easily can talk, you can listen the other sounds. So unlike the light, which can travel through the empty vacuum of space, the sound waves are a mechanical wave. Sounds are mechanical wave. They are need a physical object, a physical material medium to travel up one point A to one point to point B. Okay. No sound in the space because the space is a vacuum. It's contain the virtually no particles. Okay. So if you are surface on the moon, you try to talk to your friend, you speak, but your friend cannot listen because the medium is not present here. And same to same situation, you are on Earth. Where on Earth doesn't matter. You speak, you say hello. Your friend definitely listen to what you say because the medium was present here. Your sound, you produce the sound, the particles carry this energy to forward to your friend. The it's the astronaut on the moon cannot be hear each other speak directly. They must use radio. If they use the radio, it's mean the radio waves can travel medium, without the medium. Okay. If they not cannot travel without the medium, with the medium, if the radio waves can travel, only that can travel with the medium. So also we cannot use in the moon surface. If we use on the moon surface the radio waves, it means they they don't need a medium to travel 1.2 point. Okay, we can understand this. The sound need a medium by the bell jar experiment. The classic physics experiment proved the sound cannot be propagation in the vacuum. We take a jar and that is a two threads and is a electric bell and we tightly make the air tight by the putting cork and these are wires. When we wire connect the valve was ring and here is a vacuum pump. So is that is full setup is airtight. Okay, we can suck the air by this vacuum pump and put the air by this vacuum pump. Okay, no other no other options. Okay, so when when we when we uh, put the wire on the plug, the the hammer was hit the bell and produce the sound. Okay, the hammer hit the bell and put the sound, and we start vacuum pump. When we start vacuum pump, they slowly suck the air out of the jar, and the slowly suck the air same to same time. The sound of bell is faded, slowly faded, and completely when the completely mm, the completely vacuum pump make this in the vacuum pump make vacuum in this the jar. The sound you see the hammer hitting the bell, but you can't listen the sound because there is a no air particles. So there is a no air particles, that sound cannot travel. When the and when we start again the vacuum pump and return the air, you you notice the slowly the sound was increasing, and when the full of jar filled with the air, and you can you can feel the intensity of the bell ring. Okay, it's me. The this experiment shows the sound to travel to here out of the jar. They need to medium. medium of propagation. In the gases, the particles is very far. In the liquids, the particles very near to compare to air. But in the solid, the uh, particle of matter is very enclosed, very closely, tightly fitted. Okay, if we compare to liquid and gases, when object vibrate, they create the vibration and also create the surrounding particles vibrations. So the particles of surrounding when in the air is very far, the particles very far, so they take time to transfer energy. In compared to liquids, the particles very near, so they take less time to compare to air to transfer the sound energy. But in the solid, the particles very close, so when the object create the sound, they very fast. They fast transfer. They transfer the energy, sound energy very fast. So in the solid, the sound speed is very fast. In liquid, the particles close but not very close. So they slower to solid but faster than the air. Okay, waves communicate the underwater. The In this matter, the waves communicate with the water by the sonic sounds. Okay. In the gas, the sound travels slowest. Okay. Like here, the the sound speed so very fast in the solid and slower than the solid in the liquid, but and very slowest in the gases because the particle is very far and to transfer the energy is take time. Okay. The sound travels slowest in the gas like air because the particles are separate far apart. This is how to normally hear speech. How sound waves travels. How do sound waves travels? We learn in this slide. So the sound travels through the air. We The previous slide we learned the how the sound to travel. The sound travel through the air by the particles of form of longitude waves. Okay, when the object vibrates the forward and pushes and compresses the air in the front of it. This is speaker and this is speaker drum. Okay, so I tell you in the I tell you the previous slide did the forward and back movement. So when the speaker drum move the move from main point to A point, extreme A point, they compress the air particles. They compress the air particles. So air particles very come to very closest. And then we're back to extreme position B. They create rarefaction. Okay. And then to come to main point, again to main point. And then after again repeat. So they create compression and rarefaction, compression, rarefaction. So so when the when the object forward to its push to compress air in front of on it and creating region to high pressure called is compression. Okay. When the air drum is pushed forward, they create pressure called compression, and when the object move backward, is create the region of the low pressure. Is a lower pressure, refraction, rarefaction. Okay, whereas the particle are separate apart is called the rarefaction. The series of compression rarefaction move towards carrying the sound energy. So the sound energy carrying by the compress air compression of the air and rarefaction of the air. Okay, when both of us happen, the sound is waves travel. Okay, so we can understand the wave property by this and to crust. When the compressions is happen, they create crust, and the rarefactions happen, they create through. Okay, every time we measure the wavelength, every time we measure the wavelength, we take both of the crust points, and otherwise we take the through points. Take same. We cannot take one through point and one to crust, and so we can say that is a wavelength. Okay, the lightning and vs thunder. Lightning and vs thunder. In the dry day and dry room, the sound travel to 343 meter per second. But the speed of light, the 13 crore meter per second. If we if we see that is a major difference between the sound travel and the light travel. Okay. So when we the thunder, the lightning happen. First we see lightning because the light speed is 13 13 13 crore and the sound speed is 340 meter per second. 13 crore meter per second is the light speed and 340 to 43 meter per second is the sound speed. So the speed of the light is very fast, so we can see first the lightning and the sound travel very slow to compare the light. So we listen the thunder sound very very late. Okay, the sound produced by the humans. The sounds produced by humans, how do you listen my sounds by the ears, but how I produce the sound with my throat. And throat we have the vocal cords. Okay, and in vocal cord we call voice box. Also we say is the Adam apples. When you put your fingers on your throat, you feel a tiny little hard bump, and when you try to swallow your saliva, you feel that the bump is slowly moving. Okay, the two ligaments called vocal cords is stretched across between the larynx in such a way is the leaf as a narrow slit between the narrow slit between them for the passage of air. When lungs when lungs pass the air through the vocal cords, the vocal cords like this. Okay, for the different kind of voice, the slit size is maybe different. Sometimes it's very thin and sometimes very open. Okay, so for that kind of voice, they can adjust the vocal cord was adjust and make the sound. Okay, when the lungs pass air through vocal cord, they vibrate. The ligaments will vibrate. The air come from the slit and they make vibration in this vocal cords and we produce the sound. Okay, and this is the epiglottis. They protect to our lungs to the food cannot be go in the lungs. Okay, there's a vocal cords. They ligaments. They vibrate by the air and so produce the sound. And it is a trachea, our throat. Okay, and how we speak the mechanism when our lungs the force air up to through the narrow slit between the vocal cords. The vocal cords are vibrate rapidly. The vibration produced and the sound is recognized as the human voice. Okay, the vocal cord slit is vibrate and produce a sound and is recognized as a human voice. Pitch control: the muscle attached to vocal cords can make the cord tight or loose. So when the cord is tight, the thin, the voice pitch is high, and when this the loose and thick, the voice is a low pitch. So we can so we can adjust the pitchness of the sound by the adjustment of muscles of the vocal cords. Okay. Okay. And the more about the topic we'll learn in the next classes. Thank you for today.